So finally, I want to talk about the word back propagation, which is a word that you would um, notice if you're taking other neural networks classes. And this is more of a terminology note. Um, if you're reading sort of popular articles on neural networks, um, people might say something like, "Hey, I trained my deep neural network using backprop," which is short for back propagation. Or people might say, "We get the gradient using backprop," or something. So you might see these two kinds of statements. This term itself, backpropagation, is from the 1980s in an important paper which made some innovations in neural networks. Uh, we'll talk about that in a second. Um, okay, so what does this word mean? So when people say we get the gradient using backprop, namely this sentence, it just means that they use automatic differentiation to obtain the gradient of your function, of your loss function. Okay, that's all that means. Using backprop to get the gradient just means automatic differentiation, which just means chain rule. Okay, that's what this sentence means. Um, and then this sentence, if someone says, "I trained a deep neural network using backprop," I find those kinds of sentences imprecise. Um, but it's conventional, unfortunately, in the field to make statements like that. Um, what people mean by a statement like that is that they use automatic differentiation to compute the gradient and then use some kind of gradient based optimization to find the minima of the loss function. Okay, so that's all those terms mean, or those sentences mean. Um, why is it called backprop or backpropagation? Um, what is a neural network? A neural network is like a bunch of inputs and then a bunch of layers and then a bunch of outputs. Let's say this is the output layer. This is the input layer, X. The output is Y. And let's say the purpose of this layer is to transform X into F1 of X. And let's say the purpose of this layer is to transform F1 of X to F2. And then the purpose of this layer is to transform F2 to F3. Okay. So what do we want to do when we are training neural networks? Um, X, F1, F2, F3 are basically the inputs to the various layers. And then there are these additional parameters, lambda 1, lambda 2, lambda 3, which are like the weights and biases that correspond to each layer. Okay. Um, and when we want to do gradient descent, we want to differentiate basically something like y with respect to lambda 1, lambda 2, lambda 3. More specifically, we want to differentiate the loss function, but let's just say we want to differentiate y, the output, with respect to lambda 1, lambda 2, and so on. Again, these are all lots and lots of variables, right? Um, so dy by d lambda 3 is just going to be df3 by lambda 3, and f3 will directly depend on lambda 3, okay? And dy by lambda 2, the output by lambda 2, the one in the previous layer, is given by basically chain rule of differentiation. So it's going to be df3 by df2, df2 by lambda 2, because f2, this function that corresponds to this layer, will directly depend on lambda 2. And then dy by lambda 1 is going to be the chain rule applied this way. Just to sort of paint a simple picture. So all we're doing is doing chain rule, and then we are propagating the partial derivatives back through the network, right? So we're propagating the chain rule back through the network from the output layer. And hence it's called back propagation, right? So there's this backward sort of propagation of, I suppose, these partial derivatives. So that's why it's called back propagation. When you use MATLAB's train network to do deep learning optimization, MATLAB implicitly uses back propagation, or basically automatic differentiation, to evaluate all the gradients and so on to do gradient descent. Okay, and we already saw how to use DL array and DL gradient to explicitly do automatic differentiation in MATLAB. Okay, so that's all. That's the end of this little terminology note. Other software packages in Python, let's say, will have a slightly different way of um, potentially explicitly doing backpropagation, sort of like declaring something like DLRA or something like that. So we'll talk about that when we get to Python.